In this video, we'll review the naive method and the average of historical values or past values methods presented in section 6.2 of chapter 6, tables 6.7 for the naive method and 6.8 for the average of past values method. If you don't have your table set up like this, you'll want to take a moment, set it up. You don't need to worry about these symbols as much. They're here mostly for your use. For the naive method, we're going to just take the previous period's value and assume that that will carry over to the next period. So our forecast for period 2 will be the actual value from period 1. That means that we don't have a forecast for period 1, so in this instance K is going to equal 1. It's the number of periods that we use to create the forecast, so we use this period to create the forecast. Since I've used a relative cell reference here, I can just copy this down, and you can see that I get the previous period all the way back as the forecast. Then we'll calculate the forecast area, which is simply the time series value less the forecast, which is y hat. Here's the formula for that here. So we'll take the value and subtract the forecast. And we'll copy that down. Now we want the absolute value of the forecast, so we'll use Excel's absolute value function to get the absolute value of the forecast error. Then we want to square that for each period, equals the value raised to the second power. Then we want to find out the percentage error. So we take the value E sub t, the error, which we calculated here, and we place that over actual value. I'm going to take some decimals out of this. Actually, I'm just going to go ahead and multiply it times 100 at this point, and I'll do that in Excel by converting it to percent. You see it's 0.91 here. If I convert it to percent at this point and add a couple of decimals, I've essentially multiplied that times 100. I've moved the 2 decimals. I've moved the 1 and the 9 to the left of the decimal. Then I'll just copy this down. Then I need the absolute value of the percentage error. So I use the Excel function to get the absolute value of that. Convert it to percent again. Put a couple of places behind the decimal. Copy that down, and I've solved for that. Now I want some sums here that I need to be able to use. So I will draw a line here and then get the sum with this column. Excel is trying to help me out here, but Excel is wrong. It's taken the absolute value, you can see, and I don't want that. I want the sum. Here it's taken the square. I don't want that, so I'll delete these two. And I'm going to just copy the sum across here. Convert these two to percentage. And then increase the decimal a couple. All right. Now I want to calculate the mean forecast error. Have the formula for the mean forecast error there for you to see. Formula for the mean forecast error. The mean forecast error will just take the sum of our forecast error, which is here, column D, and we'll place it over our sample size, which is 12, we have 12 weeks, minus K, the number of periods we used in the forecast, that was 1. Put in forecast period 1, and that gives us the mean forecast error. I've included the mean absolute error formula here. And the mean absolute error, all we're taking is the sum of the absolute values of our error and placing that again over n minus k, 12 minus 1. We get our mean absolute error. I'll take out some decimals. Mean squared error, here's the formula. Here we'll take the sum of the error squared column right here. Place that over n, which is 12 minus k, which is 1. And we will take out some decimals. That gives us the mean squared error. Now we'll take the mean absolute percentage error, the error over our time series value, which is represented here. We'll take the sum of that. And over 12 minus 1 n minus k. We'll multiply that times 100 by converting it to percent using the percent function in Excel. We'll add a couple of decimals there. And our week 13 forecast is just the final period here, week 12. In the naive method, we just use the previous period's value for the forecast. So week 13 would we use week 12's actual time series value, and that would become week 13's forecast value. Next, we'll move on to table 6.8 in chapter 6, which is forecasting using the average of past values method. Same titles. We're going to use the same data. We'll use the same formulas. We'll find the same mean error measurements. We're just going to calculate the forecast a little bit differently. In the average of past values method, we're going to use the average of all of the past values. And of course, the first one for period 2 is simply going to use the value of period 1, and then we will go from there. This period will be the average of periods 1 and 2. The forecast for period 4 will be the average of periods 1, 2, and 3. So the averaging method will just keep up with us as we work our way down. I'm going to use a combination of absolute and relative cell references. In order to calculate this quickly, I'll use the average function. And then for this, I want the average of the 2 previous periods here. What I want to do is I want to anchor B3, so I'll put my cursor on B3, press F4 one time. I want to lock that because as I copy this down, I want this area to grow. And by anchoring the first one, this second reference will move down relative to my position, but the first reference will stay locked. So when I press enter there, I just go ahead and autofill all the way down. Let's clean up these decimal places. We'll put in a couple. And you can see I'll place my cursor here and press F2. That's worked. The first cell reference was locked, and then I've just copied all the other ones down. Now I'll just go through and work out this notation here, solving for each one of these. So I'll solve for error by taking the actual value less the forecast value. And I'll copy that down. Now I'll take, and let's clean these up a little. Then I'll take the absolute value of our error. Copy that down. Okay, clean it up. And I'll square it. raised to the second power. Again, I'll just copy that down. There we go. And I will take error column D over the time series value for period 2. There we go. I'll go ahead and reduce that a little bit. Actually, I'm going to make that multiply it times 100 essentially by converting it to percent. And I'll give it a couple of decimals. I'll copy that down. See that this equation down here requires that you multiply times 100, so I've just gone ahead and done it all the way down here. Same here then, I will take the absolute value of my percentage error. Again, convert that to percent, add a couple of decimal places, copy that down. There we go. Now I'll do some totals. Again, draw a line. Go ahead and get the sum of my forecast errors. Excel tries to help me, but Excel is mistaken. So I'll just copy this right over the top of these. That gives me the values that I need. I'll take these two and turn them into percent. Give a couple places behind the decimal. Now I'll calculate my mean forecast error. I have the equation for that here. I'll take the sum of E sub t, so the sum of the forecast error, and place that over n minus k, in this case 12, again minus 1, k is 1 again, and let's get rid of a few decimal places there. I have the formula for the mean absolute error. Again, we'll just take the sum of the absolutes of the error and place that over 12 minus 1 n minus k. Get rid of some decimal places. Mean squared error. You have the formula for that right here. I'll take the sum of this squared forecast error and place that over in n minus k, 12 minus 1 in this case. Give some decimals. The main absolute percent error. We'll take the sum of our absolute percent errors and place that over n minus k. Convert that to a percent, add a couple of decimals. There's our value. And the week 13 forecast is simply the average of all of the previous actual time series values. That gives us 19.25. That is how you find the mean errors and the following period forecast using the naive method and the average of past values method.